Okay, so a few problems from last night's homework that I want to check with you. Number one, it said cosine x, tangent x. Well, first thing you should have noticed is the tangent can be changed out. And what's tangent? Sine over cosine. And I have cosine x here. Remember that that can be put over 1, and then I can see that that cancels that. Final answer, sine. That was number 1. Should have been sine x. Any questions about that one? All right. Let's next go to number 7. Number 7. It says, it's on the front page, isn't it? Am I on the wrong worksheet? Oh, just so you know, that's the first problem on today's homework. Okay, sorry. Let me look at the old one here. I did not need to do number 7. Sorry. Okay. Is this the same as... It is! It's the same as 2a. Cool. So grade number 2a is this. It should have come out to sine x. And then we will do 2b. 2b is cotangent x, tangent x. And if you're not, don't just grade right now. I mean, also think about how to do these, because this is a review of yesterday. All right. And then think about nominations for other problems. I said I'd take easy ones, so think of some more out there that you'd like me to grade out of the 5 that we're going to grade for today. All right, moving on. Tell me that in a minute. Cotangent. That's like tangent except flipped. So tangent was sine over cosine, so cotangent will be cosine over sine. And that's my first thought, and it'll probably work, but we'll find out. All right, tangent is, oh, wait a minute, this is the hard way to do it, but it's going to work. What's tangent? Sine over cosine. It'll work. And there would have been a faster way. Do you get that this and this are inverses of each other? And what do inverses make when you multiply them? They make 1. Otherwise, I could have just done what I just did. Done cancel, 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 cancel. Everything turns into a 1. So it's 1 over 1, which is 1. Either way, 2b came out to 1. All right, nominations. 1a I did in class. I'm not going to do that one. 1b seems reasonable. Did I do that one in class or not? Okay, so 1b. All right, that one says, actually, Mr. I don't want to say your name on the video. Could you read me number 1b? Secant and that it? Cosine theta is greater than 0. Okay, so if cosine's positive, all students, if cosine is positive, then we know it has to be in, it can't be there and can't be there. That way. Okay, and if tangent is positive, then it can't be there. So it must be here. All right, now, if I'm doing tangent is 3, tangent is opposite over adjacent. The opposite side is 3, and the close side is 1. I've drawn my triangle kind of funny looking, but that's okay. Now, the next thing I need is to find this other side. It's always a square root, and then I take the other two sides squared and add them together. 3 squared is 9, 1 squared is 1, add them together, makes 10, squared 10. And now I can do secant, cosecant. Now, if you've memorized SOHCAHTOA, have you also memorized, girls, please don't turn it on. What's that SOHCAHTOA-like thing except can be used for these guys? Remember? Cho, sha, how. In case you have no idea what I'm talking about, it's just SOHCAHTOA except with the O and the H reversed, and the A and the H reversed, and the O and the A reversed, like SOHCAHTOA except the every letter's reversed. Okay, so otherwise I have to go through each one and go, okay, I don't want to do secant. I want to do the one that's like secant, which is cosine, except I got to flip it over. But if I do this way, I got my secant here. I just remember this is cotangent because there's 2 c's. Okay. Anyway, secant is hypotenuse over adjacent. So in this triangle, hypotenuse is the root 10 over the adjacent is 1. So it's root 10 for that one. And the cosecant is like sine except flipped. So instead of sine is opposite over hypotenuse, it's hypotenuse over Let me think. Oh, I get it. So this is close, man. Yeah, sorry. So it's hypotenuse over opposite. All right, so hypotenuse is square root of 10, and the opposite is 3, so it's root 10 over 3. Go. Took a while, but those are the two answers you need for 1B. Any questions on that one? Okay, we've graded 3 of them so far. We're going to grade actually, well, anyway, give me a suggestion for another one. 2C is in cat. All right. Let's go to 2C. In the back row, Mr. A, would you read me 2C? Minus pi, minus y, okay. So, that sine of pi over 2 minus y gets replaced with its cofunction. What is signs like Batman and Robin, or pilot and co-pilot? Sine goes with what? Cosine. Okay, so this is cosine, and then if you know this one, it's just y. The combination of this and this is cofunction. One of them always has the parentheses with the pi over 2 in it. The other one's just the letter. Okay, so anyway, it's secant times cosine, and secant can be replaced with something. Secant is the flip, or 1 over what? Cosine. So when you replace that, all of a sudden now, it's super easy. It's a multiply across the top, across the bottom, and everything cancels. You get 1s, and you get a 1 again. There we go. Now, for the last point, this one's going to be a little brutal for some of you. My new style of grading the homework is going to be, it's going to give on one hand and take away on the other. I'm only going to put this in out of 4.5 points, so you'll have a very, very good chance that you'll have a 5, many of you, and you will get 5 out of 4.5. It gives you a little bit of extra credit. Or if you have a 4, then you'll have a 4 out of 4.5. Get what I'm saying? So it's going to help you on that. But on the other hand, if you don't finish your homework, it is going to punish you. All you had to do to get this last point is to have finished every problem. It can be wrong, but if you skipped problems, other than the ones I told you to skip, remember I did give you a few you could skip on purpose. Like 1D was a skip on purpose, and there was a couple others that were skip on purposes. But if they're not supposed to be skipped and the kid just didn't do them, then they lose that last point. Okay, so that means, let's say a typical kid. They got 1 wrong of the 4 that we graded. Okay, so they got 1 wrong for that. And let's say they also didn't finish the thing. Now they got 2 wrong. So you're going to give them a 3 out of 5. But when I put it in the grade book, it'll actually come in as a 3 out of 4.5, which isn't as bad. So it'll encourage kids to get their homework done for a free point at the end. All right, there we go. Give it back. Yeah, you put it out of 5. You don't think about the 4.5 thing. It'll just help you in the grade book. Yes. That's no extra penalty. If they just didn't finish, they just lose the 1 point. It's not like you multiply out how many they didn't finish. It's just finished or not finished. They only had 2 right of the 4 I graded, and they also don't get the other point for finishing. They only get a 2 out of 5. All right, so there's a little review of yesterday. Now I want you to start getting good at this. So to be able to be good at this, when you look at a problem, you've got to see what could possibly replace what. Okay, so like for instance, here's a typical problem off your worksheet for today. It says cosine x, and it says 1 plus tangent squared x. What you should be thinking when you see this is like, what are my options for this? Like cosine. You could yoink that out and put in, well, a couple different things. If you wanted to take out cosine, what's an option? If you want to take that out, what could you put in instead? 1 over secant. Now that one doesn't feel like it helped very much, but wait a minute, maybe it will when I look at the other side. What could I put instead of 1 plus tangent? Well, I'm going to remind you on this one that there's a little saying that helps you remember one of these little rules, one of these identities. Do you remember that nifty little saying I taught you yesterday? The one with the tan is what we seek. And therefore, this is a secant. Just be careful. A common mistake is to just put secant. It's actually secant squared. Okay, so this little thing right here, 1 with the tan is what we seek. It means I have this. And now, when this happens, do both of the secants cancel? No. It's sort of like having this situation. 1 over x. Hold on. We're freaking out here. 1 over x times x squared over 1. It's kind of like that. You can't just go, oh, I'm canceling all the x's. It wouldn't work. You got 2 of them on the one side, that it's an x squared. So you could cancel one of the x's and you could cancel the squared. Well, just like that on this, I can't just cancel out all my secants, but this secant will cancel, and one of these 2 secants will cancel, and I get rid of that, so there's only just plain secant left. And if you ever get it down to just one function, then you're done. All right. Which do you think is worse? Having a phone in your lap and reading it, or having a book in your lap and reading it? I think actually the phone is worse. I'm just saying that for somebody's benefit. Anyway, yes. No, because I've replaced the 1 over tangent, or 1 plus tangent squared with the secant squared. So, no, but think of it this way. Because this was squared, then this secant had to be squared. Because I was taking out a 1 plus tangent squared. And when I replace that, I replace it with a secant squared. I'll give you a general rule of thumb. If you're ever replacing something that has a squared on it, when you replace it, the other thing you put in will have a squared on it too. All right. So let's look at another one and just think of like, what could I possibly replace this with? Tangent has lots of options. If I say tangent of x, and here I have secant squared of x. Let's just think about tangent for a minute. Give me some options for tangent. Sine over cosine is one option. Okay. If that's not going to work for me, what else could I use instead of sine over cosine? 1 over cotangent, yep. Good. All right. Now, anytime I see something squared, I should be thinking, oh, then I got a couple different options. If it's something squared, then I could replace it with one of those Pythagorean ones. That's like, for instance, the 1 with the tan is what we see. Then that one, oh, I can replace this with 1 plus tangent. Okay, so right in there, I could put a 1 plus tangent squared. All right. So on this one, I'm not going to actually just finish it. I'm just trying to show you options. What could I put in? That's an option. What else could I put in for secant? Whether it's squared or not, I can put in its inverse. 1 over what? 1 over cosine. Okay, notice that if it's squared, this one will be squared. All right. Now I'm going to change the original problem a little bit, and let's say this had been a cotangent at the beginning in the original problem. Just plain cotangent. Then what should I be thinking about replacing the cotangent with? What's cosine? Or sorry, cotangent? Cosine over, yep. So now do you see what would happen? Look for these. Anytime you have something on the top, something on the bottom, you got to look for those to cancel. Do you get that those would partially cancel? Because one of these cosines would cancel, and one of these 2 cosines would cancel, so it's not squared anymore. So the final answer on this one would be 1 over sine times cosine. All right, last strategy I want to give you is that if you don't see another way to do it, one way that works almost every time is change everything to sines and cosines. Let's think about this. You can almost always change something to sine or cosine. I'll give you an example. Let's say you have tangent. What could you change that to? Cosine over sine, or is it sine over cosine? Sine over cosine. Okay. Let's say I had, let's see this one, sine squared. That is a sine already, right? But do you remember that one with sine squared x plus cosine squared x is equal to 1? If I needed to replace the sine squared with something else, give me options to make things cancel. Do you get how? Yeah, I could move this over to the other side and get sine alone. And I'd have sine squared x would equal 1 minus cosine squared x. That's one of the tougher ones for kids to do. So you replace this with 1 minus cosine squared x. All right, so sines can be replaced with cosines. Same way cosines can be replaced with sines. Tangents can be replaced with sine over cosine. Cotangent can be replaced with cosine over sine. Almost everything out there can be replaced with a sine or a cosine. Yes. How about cosecant? What could you replace that with? Cosecant. Yeah, that's really just 1 over sine. So many things come down to sine or cosine. How about secant? What should we replace secant with? Secant is 1 over cosine. So you can get things down to sines and cosines, and when the cool part is, when you get it down to all sines and cosines, then a lot of things will cancel. Because you have like a lot of opportunities to have like, oh, sine on the bottom, sine on the top, make them cancel. Yes. Yep. Yeah, if you wanted to use the same equation right here to get cosine alone, you would just subtract, and just do it in your head. If you just want to subtract sine x from both sides, do you get that cosine would really be 1 minus sine squared x? You get that? Okay. That's going to come up a lot. All right. So that technique of changing everything to sines and cosines really helps. It's really cool. All right. This is one of those days where you got a fair amount of time to work. And I encourage you to work in groups, because a lot of times where one kid will be like stuck, another kid can say, oh, what if we replace it with 1 over cosecant? And then poof, everything cancels. All right. There you go. A lot of time to work today. Make use of it.